Dear students in my Physics 4A, good morning. We are in continuation of chapter 2, which is about kinematic, and we continue kinematic from motion on horizontal axis to motion on perpendicular axis. So we finished equations for motion on x-axis. Now we go to motion on y-axis. What is free fall? When we say free fall mean is free fall. Free fall mean is object falls freely. What does that mean? That mean is while object is falling, it falls only and only because of its weight. Make sense? So when we jump up, then we fall. Why do we fall? Because of my weight, because of our weight. What is that weight? Weight is gravity. Weight is gravitational force from planet Earth or any planet on the object. So it's attractive. Okay? So when we say free fall, it's just free fall. We don't push it during motion. We don't touch it during motion. It just falls because of gravity. This is called free fall. If you take a look in this picture, so free fall is motion with acceleration. Okay, free fall is motion with acceleration. So in reality, free fall is non-uniform motion. Pay attention here. Please take the note. Free fall is non-uniform motion. That means is velocity or speed is not constant in free fall while object is in motion. If free fall is not constant, therefore we do have acceleration. What is this acceleration? It's called AY. What does AY mean? It's acceleration on y-axis. When in free fall. So one more time. When we say free fall is motion with acceleration. So it is non-uniform motion. That means is speed is not constant. That means is when speed is not constant, we do have acceleration. Okay? In previous lectures, if you look at these equations, guys, this acceleration in reality is acceleration on x-axis. because it's on horizontal axis. Okay, we don't put this x, maybe we don't want to make equations messy, so that's why maybe we don't put it. But in reality, it's ax, it's acceleration on x-axis. So in free fall, acceleration is on y-axis. Now, how much is this acceleration in free fall? Guys, we can find amount of this free fall acceleration. It's 9.8 meters per second squared. This is the constant value. We show it by g, okay? So in free fall, have peace in your mind. We don't need to find acceleration in free fall. Acceleration is known value. It is known value. Does make sense? So when object falls, we can measure acceleration. How much is? It's 9.8. We call it G, or we call it AY. Doesn't matter. Whatever. So it is constant. G is constant. 9.8 is known value. Let me tell you one thing. What does that mean? Watch, guys, if you go, so acceleration on planet Earth, let's call it G on Earth, is 9.8 meters per second squared. Just go ahead now. Drop. So you may have an object in front of you. Just drop it. It falls. Right? What is the acceleration during the motion? It's G. How much is? It's 9.8 meters per second squared. You may even throw the object up. Okay? When it goes, it slows down. When it goes up, it slows down. Why? Because gravity is down always. How much is that gravity? 9.8 meters per second squared. G on the moon, do you know how much is 1.6. What does that mean? Imagine this is moon surface. When you drop the ball, if you go on the moon and you drop the ball on the moon, it falls. It will fall for sure, but it will go slowly. Does make sense? So this ball on the moon surface will fall, but much slower than Earth. How much is that, G? 1.6. For example, if I go on planet, let's say Jupiter, do you know how much is G on Jupiter? It's like 24.7 meters per second squared. It's almost 2.5 times gravity acceleration of planet Earth. So that means this. If I assume, for example, let's assume this is planet Jupiter. And if I drop this ball on planet Jupiter, it will fall very, very faster than Earth. 2.5 times faster than planet Earth. Okay. If I go, for example, on Mars, planet Mars, on Mars, I think it's 3.6 or 7 is, I think it's 3.6 or 7, so one of that. Okay. You know, if we assume this is Mars, drop it. It will fall, but faster than Moon, correct? Slower than Earth. So gravity acceleration, every planet, every stars, they have gravity acceleration. Let me tell you, G for star sun is 274 meters per second. Look at this. It's very big. It's almost 270 times of planet Earth. So gravity acceleration G, I will mention this later in chapter 13, hopefully, and maybe at the end of chapter 8, that this G depends on size of planet and also on mass of planet. How heavy, how big is that planet, okay? So now what we need to know that G, gravity acceleration of planet Earth, is 9.8 meters per second square. Let me talk about these pictures that I have here. Look guys, in this image, this rock is actually, it has less mass, so it's lighter. This rock is high mass, or it is heavy. Okay, so when we drop these two objects, pay attention. When I say drop, drop mean is same as release. Release mean is initial velocity is 0. So there is no initial velocity. We just let it go. So drop mean is no initial velocity. So I can say V naught is 0. Drop is different with throwing. When we throwing the object up or down, we give it initial velocity. So in this picture here, what do I see? If you have two objects, one is heavy, one is lighter actually, when you drop them both in the same time, pay attention, when we drop them both in the same time, they will reach to planet surface both in the same time, and even with the same speed. For example, if this takes 2 seconds, this will take also 2 seconds. If the speed of collision with heavy rock and planet Earth is like, for example, 20 meters per second, this one is also 20 meters per second. So what do we see? We see this. Gravity acceleration is constant no matter object, falling object, is lighter or heavier, is it 20,000 tons or is it just one feather or paper sheet? They will fall both in the same time. They will hit the planet's surface in the same time with the same speed. Please remember this. Doesn't matter how heavy is object. And we do this usually in physics lab. Inside this tube, you do have a feather if you take a look. And here out of the tube we have apple. Inside tube is vacuum. So it's vacuum tube. And you know, feather is very light. It's like maybe 2 grams, less than that. But apple is like 400 grams, correct? Almost, let's say, big apple is like 1 pound mass. When we drop these two in the same time, they reach to the end of tube or to planet surface in the same time. That means is G for feather is 9.8. G for apple is also 9.8 meters per second square. I want you to keep in your mind, okay? So gravity acceleration depends on the mass of planet, not on the mass of falling object. Don't forget this. G, gravity acceleration of that planet, any stars, depends on planet, not on the falling object. Okay, so let's talk about equations now. Guys, we do have two kinds of free fall. Number one, it's called downward free fall. Number one is called downward free fall. What is that? Imagine this is a ball. Okay? We drop it or we throw it at the beginning. So it has initial velocity. Correct? It falls. So while it falls, speed what? Increases. While it falls, speed, of course, increases. So for example, if I say initial velocity, for example, is 2 meters per second, and then velocity here is, for example, 5 meters per second, and then velocity here is, for example, 20 meters per second, and then when it hits the ground, velocity is like 40 meters per second, for example. Okay, these are just assumption numbers. Therefore, I see, let's put this one V1 or VA, VB, VC, we can do it. So I see change in speed. So we do have gravity acceleration. So it is non-uniform motion. Okay. So guys, in first formula, we learned V equal AT plus V naught. This is the first equation in motion on x-axis with acceleration. Therefore, you know, this was velocity on x-axis, correct? And acceleration on x-axis. This is v is final velocity, v naught is initial velocity. So I can write this equation v equal, instead of a, just put g, t plus v naught. This is first equation in downward free fall. The only thing that we need, you need to put instead of acceleration, g, which how much is g? 9.8 meters per second squared. It is okay if you put Vy, and it is okay if you don't put y, index y. Okay? So that's not big deal. You feel free to put index y or not. I usually don't. Then the second equation that we learned, it was this. X equal 1/2 at squared plus v naught t plus x naught, correct? Therefore, remember, x is called position on, final position on x-axis. X naught is called initial position on x-axis. So my equation becomes this. Instead of x, we are going to have y equal 1/2. Instead of a, I'm going to put g t squared plus v naught t plus, instead of x naught, y naught. The third equation that we learned, it was independent of time. V squared is v naught squared plus 2a delta x, correct? Therefore, I can write v squared equal v naught squared plus 2, instead of a, I'm going to put g, instead of delta x, I will put what? Delta y. Feel free if you want to put index y for velocity. And last equation was average velocity is v naught plus v divided by 2. So here also I can write v bar is v naught plus v divided by 2. So these four, they are downward free fall. Yes, these equations are for downward free fall. Now, let's talk about what is y. Look guys, in downward free fall, the point that we drop or draw the object, it is called origin. So origin always is the throwing or dropping point. Which we know one thing, what is that? We know this is x and this is y-axis at this time. So everything is positive, throwing or dropping point. So here we can say why not? Because its origin, it's 0, initial height, initial position of the ball. So this is initial position of ball in free fall on y-axis. Let's say this ball, so here is O or origin, here is point A, here is point B, here is point C. At point A, of course you do have YA. So this is what? Position of the ball on y-axis at point A. At point B, of course we do have YB. Makes sense? At point C, we do have what? YC. So Y is position of the ball at time t on y-axis. Okay, so remember y, it's same as a height. So let's do one example. A ball is thrown down with initial velocity of 5 meters per second from height of 50 meters. From height of 50 meters above ground surface. Find what? Part A. Time from throwing point to, hitting point. B, what is speed of ball, or it's better to say velocity. What is velocity of ball? just before hits ground. See what is velocity of ball at what? 20 meters above ground. D at what time after throwing velocity of ball is 20 meters per second. These are kind of questions that you may have in your exam. So I want you, all of you, please to focus and let's see how can we solve problems. Okay. So it says a ball is thrown. We have to draw a picture. A ball is thrown down with initial velocity. So what I am going to have, this is ground, and here I do have a ball, okay, and then we throw this ball with initial velocity of 5 meters per second from height of 50 meters above ground surface, correct? So remember, this is your origin, so this is my height. So if and everything is positive, downward is positive. So if 0 is origin, so this point is what? 50 meters. I know in reality it's negative, but because everything is positive, let's choose it by positive. It says find time from throwing point to hitting point. Okay, so part A. Guys, verify knowns and unknowns. So what I am going to have, let's choose always, we can say this is point A, this is point B, correct? So question says find time from throwing point from point A to hitting point, which is point B. So this is my path. This is my path. We can call it path AB. So we will solve equations for path of AB. What do we have for path of AB? Verify knowns and unknowns. So initial velocity at point A is 5. That's the question says. Final velocity at point B is unknown. Time from A to B is we don't know. Correct? This is what question wants. Okay. Now, velocity, final, initial, and time. So what equation is the best among of these four equations? Which one is best equation to can find final velocity? Answer is number one. Number one, it says v equal gt plus v naught. So v equal gt plus v naught. So what is this v? It's final velocity. It's vb, velocity at point B. G is g. What is this t, guys? It's time from v naught to v. So this t is time from A to B. So my equation for path of AB will be this. Now I'm going to substitute. VB is unknown. G is 9.8. Let me see. Okay. We have time, which it's unknown. And we have initial velocity, which is 5. Correct? This doesn't help me. No help. I can't solve this problem, this equation. Why? Because I have two unknowns. I have two unknowns. But remember, we did not use all datas of the problem. See? So I do have height from point A to point B, which is 50 meters. I do have height. Therefore, this equation will not help me. So, if I go on second formula, which y equals 1/2 gt squared plus v naught t plus y naught, pay attention, this y is ya, 1/2 is 1/2, g is g, time is path of AB, initial velocity is velocity at point A, correct? Time is time from A to B, plus y naught is y at point, sorry, this is B. Make correction here, ya. Now, let's substitute. YB is 50, 1/2 is 1/2, G is 9.8. This is square, put square over there. This is T squared plus VA is 5, T is T, so I don't put AB, and YA is 0. Therefore, I am going to have 50 equal 1/2 times 9.8 will be 4.6, sorry, 4.9, T squared plus 5T. So this is my quadratic equation. Make sense? So how can I solve this quadratic equation? T will be, it's algebra, minus b, which is minus 5, plus minus radical b squared will be 25 minus 4 times 4.9 times 50, correct? Divided 2a, divided 2 times 4.9. So go ahead, find the answer, please. Tell me how much is the answer. Did you get the answer? Answer? Aidan, did you get the answer?
Do you want both the positive and the negative version of the answer?
Yes, please. The positive one is 2 point.
The positive one, I keep on getting an error. I don't know why.
Same here.
I think it's a
So
miscalculation.
for the
I think
radical, it's negative. That's
there
why
is
it doesn't.
Yeah, I think I think there's only one answer. I think it's only negative.
redo it.
Yeah.
Okay, so we get two answers. One is positive, the other one is negative. This negative answer is not accepted. Why? Because time cannot be negative. So falling time from point A to point B is 2.72 seconds. So circle your answer and show all your work in quizzes, exams, like exactly how I do here. Let's go on part B and you will do part C. Part B. Part B says, what is velocity of ball just before hits ground? Okay, what is velocity of ball? Look guys, we are again in the path of AB, correct? We are in the path of AB. So write initial velocity, final velocity, time, position, and acceleration. These five quantities in kinematic are required always in every section. So at point A, we do have initial velocity, correct? At point B, I don't have velocity. I do have height. It's given. And what else? All right. So Question wants me to find what is velocity of ball just before hits the ground. That means is velocity at point B, correct? What is my equation? Watch it. We have initial velocity, we have final velocity, we have height. I believe this equation, which is third one, is wonderful. Third equation says v squared is v naught squared plus 2g delta y, correct? So this v squared is vb, final. V naught is initial. 2 is 2, g is g, and delta y is y minus y naught, or yb minus ya. Does it make sense for path of AB? So VB is unknown. VA is given, it's 5 to the power of 2. G is 9.8, correct? YB is final height is 50, YA is 0. Therefore, VB squared is, find answer please, 25 plus 100 times 9.8 will be 980. So if you take square root of that, I got 1005. So if we take square root of that, will be 31.7 meters per second. This is velocity of ball just before hits ground. Okay. I can do by different methods. Part B, I will say, or, you know what guys, what if I use the first equation, which is V equal gt plus V naught? Pay attention. This V is final velocity, g is g, time is from A to B, and V naught is what? Initial velocity, which is at point A. Correct? Watch it. They want me to find VB. Okay, VB equal, G is 9.8. TAB, we don't have it from question, but we found it here. In part A, we already found it. So I'm going to put it 2.72. And VA is 5. So VB becomes what? I promise you it will be same answer. If not, we did it wrong. I got 331.656, so it will be 7 meters per second. So either way works. Okay? But what I suggest you, let me tell you this. Guys, you may get wrong answer for part A. And if you use that wrong answer in part B will be wrong too. So I suggest you always try to use given data of problem. Okay, so now I want you to work on part C and D. All right, let's do part C. It says, what is velocity of ball at 20 meters above ground? Okay, watch guys. So we throw the ball from point A, correct? And let's say here is ground. As I said, point A is origin. So question says, what is velocity of ball at 20 meters above ground? Pay attention here. So if point A is 0, this point is 50, correct? Which is point B. So in part C says, what is velocity of ball at, pay attention, 20 meters above ground. So 20 meters above ground is here, correct? So if I say this is 10, this is 20, this is 30, this is 40, and this is 50 meters, 20 meters above ground surface, it is here. So let's call this point C. Okay, so let's write knowns and unknowns. Initial velocity at point A is 5, correct? They want me to find velocity at point C. And I do have, pay attention, what is final position of the ball in the path of AC? I do it for path AC. Initial height position, initial position is 0 and final position is 30, not 20. Be careful. It says 20 meters above ground, but in reality it's at 30 meters. Its final position is 30 meters compared to origin. And yeah, that's all. So let's see how can we do this again. We do have initial velocity, we do have height, and we want final. So I believe this equation is the best one. Alright, so watch it now. V is velocity. Which one? Final. For what path? For path of AC. Final is C. A is initial, C is final. V naught is VA. 2 is 2, G is G. This delta Y, it's delta Y in the path of AC. Okay? So let me write it again. Watch it, guys. VC is unknown. VA is 5. 2 is 2. G is 9.8, correct? And delta Y, AC in the path of AC is final position minus initial position. Did you get this? So let me rewrite it. This will be VC squared equal 25 plus 2 times 9.8 times You tell me, what is YC? How much is YC?
30.
30, yes, it's final position. YA, 0. Therefore, we can find what? VC. Go ahead, find it and take square root. You will have two answers, but which one is accepted? The one that is positive, because everything we assume that it's positive in downward free fall, which it is. So how much becomes answer?
24.8 meters per second.
Yes. 24.75. I go with 75. Choose always 2 decimal point is perfect. So 24.75 meters per second, but positive. Good. Let's do part D. It says, at what time after throwing velocity of ball is 20 meters per second? So part D, I'm going to draw a picture again. So we throw the ball here, correct? Here is ground. It says, at what time after throwing the ball, velocity is 20 meters per second. Okay. You know, I don't know where is that, but maybe somewhere here, velocity is 20 meters per second. Okay, what I am going to do, I'll pick this point again, point A. This was already B. I did it for C, so I do this one D. So now my path is AD. This is new part of problem. Let's verify knowns. Velocity at point A is 5. Correct? Velocity at point D is given. Now, they want me to find time from point A to D, because it says at what time. Okay. I believe this equation is the best. V equal gt plus v naught. Final velocity, initial velocity, and time. So V, it's Vd, G is G, this T is time from A to D, and V naught is VA. So Vd is 20, G is 9.8, time is unknown, and VA is 5. Therefore, we can find time. 15 divided 9.8 will be 1.5. I think 2, huh? 15 divided by 9.8, 1.53 second. So these are how can we solve problems in kinematic. Draw picture, label question, section by section, part by part, by English letter A, B, C, D, and verify knowns and unknowns for that section, write equation and substitute. This is the way, the method we can solve problems in physics overall. Now, the last topic, it is called upward freefall. What is upward freefall? It is at this time we throw the ball up by initial velocity v naught, and ball goes up. As it goes up, velocity decreases and finally stops, and then starts to return to initial point. This is called upward freefall, and it makes trajectory a path like this. But it's on y-axis. It's all on y-axis. What I am going to do, pay attention here, always very quickly verify your coordinate system. This is y, and origin is here. So at this time, upward direction is positive. So here, upward direction is positive. That means anything above origin is positive, anything in opposite direction of positive is negative direction. But remember, in downward free fall, here, in downward free fall, downward direction is positive here. Don't forget this, please. Write it in your note. In downward free fall, so let me write in downward free fall, downward direction is positive. In upward free fall, upward direction is positive. Okay, therefore, guys, gravity always is down. So if I am going to write my equation, pay attention here, V, the first equation is this, V equal, please put a space between equal and G, V equal GT plus V naught, Y equal, put a space here, 1/2 GT squared plus V naught T plus Y naught. See, same as free fall, nothing changed so far. Third equation is V squared is V naught squared, put space over there, 2G delta Y, okay, and V bar is V naught plus V divided by 2. We have 4 equations in kinematic. Now, when it is upward, pay attention, anything up is positive, downward is negative. So G is in opposite direction of positive. So G will be negative. Look at this, put negative here. G is negative. G is negative, that's all. G is in opposite direction of, main direction. So for G, you will put negative. Remember, do not say G is minus 9.8. No. I already put this negative here in equation. So you don't need to re-put it. Don't do it 2 times. Okay? So this is called upward free fall equations. Any questions, please? So ladies and gentlemen, I uploaded a video from my last semester. It was problem solving. So please, any videos that I upload about problem solving from my previous semesters, watch those also. So you may start to work on your homeworks, and next week I will go on Monday fully over equations or over homework assignments, problems, and also you may have a lab and work on your discussion. Let me know if you have any questions. Bye.